These are the problems which we come across. Classical problems of synchronization when we have more than one process in a queue, when they want to use the same kind of resources. So we come across some similar problems here. What are those? Bounded buffer problem, then readers and writers problem, and dining philosophers problem. Most common problems, right? So coming to the first one. So these three topics we'll be discussing today's session. So coming to the first one, bounded buffer problem. So let us see what is bounded buffer problem. So let us buffer means what? We are going to store the data as a temporary storage, right? So I will go for n buffers. Each can hold one item. So I have some data to be stored temporarily. So I will go for n buffers where I have n set of data to be saved. I'll save each item, data set 1 in buffer 1, data set 2 in buffer 2, so on. So I have n items in n buffers. So to handle this n data set in n buffers, I'll go for 3 semaphores here. I'll take 3 semaphore variables you can take. So I have mutex as one of the semaphore. It is a synchronization tool whose value is initialized to 1. Then I will go for a semaphore name full whose value is initialized to 0. And I'll go for a semaphore name empty with a value initialized to n. Just an example, not necessary that mutex you have to take 1 only, then full to 0. I am just differentiating. I want to use one of the semaphore with a value 1, another semaphore with a value 0, another semaphore with a value n. You can give your own name here. So let us see how to write the code for producer and consumer process. Producer means what? So finally your goal is what? You want to generate some n set of data and you want to store it in n buffers, right? Then how is it you will do? First you have to produce n set of data. Then you have to store n set of data in n buffers. Whenever you create that, I will call it as producing item. Whenever you store it in the buffer, then I will call it as consuming. Fine. So I will write a code for producing an item and to consuming item. And when you produce, you are going to add to these buffers. Right? When you consume, that means what? You are going to remove it. So the same thing is shown here. So in the do while loop, so I think last class I explained what is do loop, while loop, all that. Do loop means repeatedly you are going to execute these set of instructions. For how long you will execute? As long as the while condition result is true. Fine. So these are the set of instructions for producing an item. So what are the 3 things I have? Semaphore, mutex I have, full I have, empty I have. With the help of that, when I am executing one of the process with weight of empty and weight of mutex. What is weight of empty? Initialization value. I want to go for n buffers, right? So I will go for an empty semaphore with a value n. Same way you can go for full and mutex whenever is required. So just to differentiate. So when weight of mutex and when you set the mutex to 1, that time, what is that I am performing? I'll produce an n item. Then next time when I go for one of the operation I am done with the weight semaphore. Fine. Then I will go for weight operation you call. There are 2 atomic operations that semaphore performs. One is weight, other is signal. Whenever weight condition is executed, that time I am producing an item. Next time when I go for signal operation, you are already created that you are going to add it. So I will add this item to the buffer when the process is executing signal of mutex and signal of full. So by the time you finish adding or creating all the items and all the items are added, your buffer is full. Fine. So these are the set of instructions which we executed for producing. Fine. Same way you are going to consume it. That is there in the next slide. Fine. So next time for these are the set of codes what you call the structure of the code for producer process. Next we have the structure of the code for consumer process. Same way. Again I will execute these steps in the do while loop. Fine. The same thing. Instead of going for producing an item and adding an item, this time I will go for removing an item and consuming the removed item. Right? One side I am creating and put it in a buffer. I am ready with the data. Other side from there, say for example, I have some variables A, B, C, D, E. So in A I have produced item 1. In the B I have item 2. C I have item 3. Next I have the other side I have n buffers. 1, 2, 3, so on n. Now whatever I have it in A, I want to store it in n. 1. Whatever I have created in B, I want to store it in buffer 2. Whatever I have created in C, I want to store it in buffer 3, so on. Fine. So that is how I am going to do. So initially in the first set of code, what is that I have done? I have produced item 1 and then item 2, maybe data 1, data 2, data 3. Data 1 is going to be created, data 2 is created, data 3 is created in the first step. In the second step, data 1 I have it in A, data 2 I have it in B, data 3 I have it in C. Now, the next, what is it? I will go for consumer process. Here, what is it I am trying to do? I want to remove data 1 from A, correct, and data 2 from B, data 3 from C. That is what I will do in the first step here. Second step, consume the removed item means what is that I will do? I have already removed data 1 from A. That I want to put it in buffer 1. So I'll put the data 1 in buffer 1. From A, I have moved it to buffer 1. Same way, from B, data 2, I am going to move to which one? Buffer 2. So on. So that is called consume the removed item. You have already removed from A, B, C, so on. You are going to consume means you are going to put it in which one? Buffer 1, 2, 3, so on. So how is it you are doing in the do while loop? When wait of full is executed and wait of mutex is executed, you are going to remove each and every item. When is it you are going to consume the removed item? When the CPU is processing with the signal of mutex and signal of empty. So this is how we are going to produce and add the item in the first stage during the structure of producer process, and you are going to perform removing the item and consuming the removed item during the structure of the consumer. How to write a structure for writer process, and next set I have a structure for reader process. So to perform a write operation in the do while loop, what are step of instruction I'll perform? I'll perform the operation called writing. When is it I'll perform? I will go for wait of write. So when my CPU is executing wait of write, a writing operation is performed. So after some time, the same writer can go for read operation, right? So what is that you will do? I will go for another signal, another atomic operation signal. When CPU is performing signal of write, then you come out of the writer operation. That means what? You can go for read operation. This is the structure for writer process. Let us see for reader process. In the structure of a reader process, see, I will not go for write operation here because we know that here only writing, and you can even go for read operation, that is indirectly shown with the help of signal of write. Whereas in case of this, I will see how is it the read operation is performed by more than one process. So let us see in the do while loop again. We go for what are the variables we have? Semaphores. We have mutex and write. Mutex is initialized to 1 and write is initialized to 1. Both are initialized to 1. Fine. So now when the CPU is executing wait of mutex, what is that I will do? I want to go for n process to perform read operation. So I will take initial value for read count if read count is 1, and wait of if the signal is wait of write, that time I'll go for read count plus plus. I will also take in operation of signal. So where I want to perform this is just to check the condition. I'm checking wait of write. I have not started the read operation. When the initially I am checking when read count is 1, and when the CPU is performing wait of write, that time I am ready to do the read operation. So I start doing the read operation with the help of signal of mutex. So this is done, completed. So read operation is done now. So when you are not performing read operation, that I can show it in along with the another set of code. What is that? When I'll take say wait of mutex, but this time I'll go for read count minus. So that means indirectly indicating that. Say for example, I have n process. I will not allow all the process to do the read operation same time. So you assume that I have allowed one or maybe at a time. One by one I am doing here. One process is performing read operation. What are the other process doing then? Other process I am keeping them in the queue. Fine. So if read, I'll go for read count minus this time. So again I'll check. This time I'll check for read count equal to 0, and I will check instead of wait of write, I'll go for signal of write, and the same thing I'll take for signal of mutex. So that means what? In among n process, one is performing read operation, other is in the queue. Same way, one by one you are going to allow. Next time, whichever was in the queue, next time you are going to allow that particular process to go for read operation. This is how you are going to write the structure for a read process. Followed, students?
Yes, ma'am.
Yeah. Shall I take attendance? Then I will continue with. You can take a bowl of rice. You can go for any number of chopsticks. So you can take a state as thinking. Where thinking can be hungry and eat. So if one is eating, others are hungry. One by one, you will serve the rice so that everyone will start eating. So that's what we try to explain. So we took an example of monitor. Monitor gives effective and convenient mechanism of process synchronization. How is it will do? If for each and every process, it will see to that whether the resource is available or not. So it will try to give the access for each and every process one by one with their read or write operation, any requesting operation after the initialization of code. So the shared data I have, operations I have, initialization code I have. But again, I may face the problem of deadlock. To avoid that, we go for some conditions X and Y. So with the help of X and Y, with respect to X, with respect to one of the process, we use wait and signal operation to suspend or invoke. If it is in wait, I'll suspend. If it is in signal, I will invoke. I'll resume the process. Fine. So based on that, so when X is performing, Y has to wait. So we based on that, we try, instead of suspending the operation, we try to invoke the process which is going to be suspended and try to complete the operation one by one. The same monitor concept is used for the solving the dining philosopher problem with the help of the initialization. So otherwise they will keep fighting. No, if you don't use this concept, all the five will fight and they may not serve the rice at all. So avoid that. We go for the solution.